Hello friends! This video will be dedicated to the more or less special device, which is not a common inverter, moreover it's only a board. And in this review we will test it, speak about its advantages and disadvantages, and try to answer the question whether it is reasonable to get only the board and subsequently build a high quality pure sine wave inverter. The device comes only with this switch. I've connected these two wires together with XT60 connector and also this main socket. The only two wires soldered to this device are these two ones of the power output. The device is designed for 12 volts. Here we have the inscription. Here we have the transistors. I would like to draw your attention to the information of the power output of such devices. The device which was ordered by me was 500 watt inverter with the peak power output of 1000 watts and the continuous power output of 450 watts. But the supplier informed me that they have no such devices in stock and offered me to get exactly this device. It's also positioned as 500 watt inverter, but the peak power output amounts to 800 watts, continuous power output amounts to 400 watts, as to the uninterruptible power output, it amounts to 350 watts. So the mathematics of this device is considerably interesting. Now let's speak a bit about the application of this device. For sure, you will need the pure sine wave inverters for audio and video devices where so-called audible buzz may interfere and even damage your audio or video recording. Also, the equipment of the medical sphere, especially in ambulance vehicles, will necessarily need pure sine wave inverters, as the interference in such devices may cause fatal consequences. But also there are some relatively common devices which cannot work with the modified sine wave. For example, the more or less professional soldering iron. This is CXG E60WT. Let's try to turn it on using the modified sine wave inverter. Let's see the results. (0°) 4, 5 off. 23 off. 35, 36, 34 off. So the device refuses to operate on the modified sine wave, though there is no voltage drop and the battery is also okay. Because of this problem, I decided to get a portable pure sine wave inverter S200, but the main issue of this soldering iron is that the start current is considerably high and during the first second the protection circuit of this inverter turns the device off. That's why, for portable operation of this soldering iron, I had to use the following device. It's really a very good one, with serious quality and serious disadvantages at the same time. 22 centimeters, 15 centimeters, and a bit less than 1400 grams, which is really not acceptable for me. That's why I decided to get exactly the board of pure sine wave inverter, and I plan to build the plastic box for it. As to the dimensions, 10 centimeters, 9 centimeters, 4.5 centimeters. As to the weight, approximately 270 grams. Before we start the test of the pure sine wave inverter, let's see the modified sine wave with the help of this oscilloscope. So we see the waveform. Now let's see the waveform of this device. I really like this waveform. Let's compare it to the mains waveform. So this waveform is even better, as here we have the flat tops and bottoms. And now a pair of words regarding the operation of this soldering iron together with this modified sine wave inverter. There may be some doubts that the power output of this inverter is not sufficient, although it amounts to 300 watts. In this sense, I decided to turn this soldering iron on with the help of the APC UPS 650 watts. The screen of the soldering iron flickered a bit, but the temperature was increasing. The maximum temperature was set to 350 degrees, and as soon as I saw the temperature indication about 260 degrees, I heard a sound, then I felt a very bad smell, and here we have the result. So the capacitor is blown up. Here are the parts, the paper, also here. So don't use such soldering irons together with the modified sine wave inverters. Hope the replacement of the capacitor will solve the problem. Anyway, now there is absolutely no doubt regarding usage of this soldering iron together with a non-pure sine wave inverter. Before we start, I would like to draw your attention to the cooling system of the device. The hotter is this part, the faster is the rotation speed. But in total, the cooling management system is not so easy. I have different coolers like this or this, but this one is too small and this one has the reverse polarity. I have no need of high power output from this device, that's why I removed its cooler, and it has the same socket and the same polarity. This multimeter will test the battery voltage, this one the input amperage. This multimeter will test the output voltage, and this one will test output amperage. Here we have several bulbs. This is 200 watt bulb, 150 watt, 150 watt. All the devices are on. Let's check all the voltages and currents. 12.5 volts, 0.2 amps, 223 volts, naturally 0 amps, and here we have the pure sine wave signal. As to the thermal image, nothing in particular. 200 watts. 11.9 volts, 15 amps, 212 volts. Let's increase the load. Okay, in total 350 watts, and now 500 watts. 11.5 volts, 33 amps, 178 volts, and 1.76 amps. And now the cooler is on. It's faster and faster. We have decreased the load because of improper position of this cooler, taking into consideration the fact that there is no case and correspondingly there is almost no airflow. Let's turn the load off. In case of absolutely no load, the sine wave is dancing, but let's apply the load of approximately 40 watts. So the waveform is stable. Here we have 12.2 volts. 4 amps, 220 volts, and 0.2 amps output amperage. So this part is the hottest one. So here. Let's measure the frequency. 500,000, 49, 95, 49, no, 50 Hertz. So now the fan is on again. As to the efficiency, well, this is input power. .87. Not bad, especially for pure sine wave inverters, which have less efficiency in comparison with the modified sine wave ones. So the maximum temperature is 45 degrees. Now the waveform is stable with absolutely no load. I suspect the waveform was dancing because of insufficient airflow. Let's use this cooler approximately within a minute. Moreover, let's leave it here. And now let's check the inductive load. Let's calculate the power consumption of this device. .69 watts. .86 watts. Now let's turn this device on together with the bulbs. Okay. .500 watts? No, because the start current of this device is too high. Once again. Protection. Again. Let's decrease the load. Is it possible? Okay. And in this condition, 200 watts, 150 watts, 86 watts, 436 watts in total. No. Let's turn this device off. And anyway, nothing. Because here we have the overheat, and in such conditions the system refuses to turn on. Let's turn this cooler off in order to listen to this device. Now the system is on and the cooler is off. But let's wait a bit. No power because the system considers the conditions unacceptable. What about this position? Let's decrease the temperature So this load is too high. And here we have the light emitting diode, which is signalizing that the load was really too high. Okay. Okay. So now everything is okay. So sometimes this power consumption is too high, sometimes not. This red LED is off. So in such conditions the system decides not to go on functioning. But this power consumption is possible. Let's define the maximum power output the device can provide. 436 watts in theory. Input, output. With such efficiency. So 292 watts is really okay. In case of less power consumption of this bulb, we even may make this device provide 300 watts, but according to the supplier, the device should provide an interruptible 350 watts. I can conclude that the device with tiny dimensions and small transformer can really provide 300 watts in case of the best cooling conditions. And now let's check the power off voltage of the inverter. We will use the power supply unit instead of these two batteries. Now let's decrease the input voltage. 10.8, 10.7, 10.47, 10.40, 10.40. So in case of such batteries, it even saves the battery, which is really good. And now about the conclusions regarding this device. As to the advantages. The device has tiny dimensions, it isn't heavy at all, it can be placed in a small plastic box, it has its own cooling management system, and even in case of problems with the fan, the device will not provide any power if the board is considerably hot. As to the disadvantage, the only disadvantage I have found in connection with this device is that the information provided by seller differs from the reality. So the maximum uninterruptible power output amounts to approximately 300 watts, and according to the seller's information, it should amount to 350 watts. The peak power output should amount to 800 watts, but I have checked the device only with the load of maximum 500 watts, which is sufficient for me. So in total, the device is really good. It has very decent quality, besides it has overload protection and also 40 amp fuse. So in case you plan to build a power bank, which also should provide high voltage with a pure sine waveform and a power output less than 300 watts is sufficient for you, this device will be excellent. Hope this video was helpful for you. Thanks for watching. Wish you good luck.